Now here we want to test the convergence, this series for convergence. And what I did was that I just, pulled up the list of rules for us. So in here, the very first thing is saying is this, that go ahead and calculate the limit of the nth term. And of course, we'll do that if it's kind of easy to do. Sometimes it's not really that straightforward. Okay. So if I look at this, you can see the limit of 1 over n squared is 0. And the limit of e to the 1 over n would be what? 1 over n as n goes to infinity. So that will become e to the power 0 and 0 times. So that'll be 0 times 1, that is 0. So, sorry, what this tells us is this, that the limit of the nth term is 0, so the test is inconclusive. So we have to do further tests. And it is not a geometric series, we can see from the form of this series. Now, if we look for P series, we see a slight glimpse of P series in here. Not exactly a P series. So if we did this, say for instance, if we removed it, then you can see this here, that this series is convergent because the series here that we get by dropping that in there, the power on n, that is p, is greater than 1. Now, so we may try to answer questions about this series based on this one. So we can do a comparison test, but a comparison test, the problem is this. If I compare the nth term here with the nth term of the series here, then this quantity e to the n will always be greater than 1. So this quantity becomes greater than 1 over n squared. So greater than being greater than a convergent series doesn't tell us much. So what we have to do is that so this one is still, okay, does not answer, right? Okay, so what we are going to do is that we are going to go to the next. So next is the limit comparison. That is, just go ahead and take the limit of the ratio of these two. That is, just calculate the limit as, of course, n goes to infinity. Okay, sorry. Just got that all wrong, not wearing my glasses, reading glasses I meant. Let me put them on. Yeah, here. So we have this. So what we are going to do is put this one on the top. Okay. And this one on the bottom. So what will happen here is this, that we will have these two cancel each other, right? And only this is going to survive. So we got what this equals, limit as n goes to infinity of simply e to the 1 over n, which is e to the 0, that is 1. So what we got here is that L is a real number and L is not equal to 0. So the convergence of this series implies the convergence of this series that we are testing, okay, by the limit comparison test, okay. So one moment, let me erase these guys here, okay. All right, and we just concluded that because of the limit comparison test, the convergence of this series here implies that this series is convergent as well, okay. So convergent. All right. Now let's just look at the way it converges, or again look at the phenomena of convergence. So what we mean is this. Say we add the 10 terms, what happens? The sum is this. Say we add 11 terms, okay. All right. And here you saw that if I leave this alone here, then that converges very slowly. Okay, but maybe this is, but now we are multiplying the nth term by e to the 1 over n. Okay, so seems to converge slightly faster than, not that much faster, but anyways. And so let's just go to, say, for instance, 100 terms, see how the change occurs there. And you can use your sum sequence feature in your calculator, all right, or in Desmos, and get this sum. So say we got up to 100 terms, and then let's go straight to 200 terms, see how it changes here. Okay. All right, so we have, well, here is still changing, quite a bit. So say, for instance, we want to decide this, that we are adding only the first 200 terms of this sequence, and we want to find the remainder. In that case, what do we mean by remainder is that this series is convergent. So this has a limit. Now, in case I stop only at 200 terms, okay, then I'm losing all the remainder, right? So we want to do this. We want to estimate what that remainder would be, okay? And in this case, we are turning lucky in the sense that we could have used before as well, that if we look at this function, fx equals 1 over x square, okay, e to the 1 over x, then this function is positive. First of all, I can write that here, that let me just write that further here. So this is positive, and of course we are talking about the interval, or on the interval 1 infinity, okay? So on 1 infinity, on this interval, this is positive, also continuous, because 1 to infinity, this is not 0, and rest is routine, so it is continuous, okay, and is also decreasing. You can take the derivative and test, but you can see this here, 1 over x squared is decreasing, e to the 1 over x will go on decreasing because the power is decreasing, and exponential is a monotonic function. So it's also, what did I say? It's also decreasing. So therefore, what will happen is, let's look. So we will have the integral test criteria apply here. And so we didn't have to use the integral test criteria to test the convergence, because we just used the limit comparison test. But here, remember this, that we have an idea to estimate the remainder over here. So this difference will mean what? That we are starting at what? N equals whatever term we stop at, plus 1 of that, right? Okay, and then that is determined by this integral starting from capital N to infinity. So we have what? This would just be less than, according to that criteria, this will be less than, let me just write the integral here, okay, from 200 to infinity, okay, of what? 1 over x square e to the 1 over x dx, okay? So according to this, because so integral test applies, and then you simply have this as the conclusion. I'm simply rewriting this. So I think we don't need that list anymore. And so let's just go ahead and calculate this quickly as a review of our integrals. This is an improper integral, as you can see. So how about this? Let's just first calculate this antiderivative, and then we shall calculate the improper integral. So if we are calculating the antiderivative, what we notice is the situation is pretty good here. Reason being that this is something that is like, this and 1 over x square. They are the two things that we have to handle. And in this case, situation is very lucky. And whenever it is, in the case it's not, we see that we go for further comparisons. So here, what we are trying is that we will just take 1 over x as u. Okay. So what that is going to give us is that negative 1 over x square dx will become du. So what we find here is that this portion combined with this, and I don't know where this x came from. That's a typo. I'll erase it. Okay, I have no idea how that snuck in here, how that walked in here. Okay, I mean, why did that? I bring it in here. I'm sorry. Okay, so here this will become what? Negative du, and this is going to become e to the u. So this will just become integral or antiderivative negative e to the u du. And I'm just going to erase this handwriting and just remove this stuff that I just accidentally brought in, and then we will go further. So let me just erase everything here. Okay. And so this wasn't here. This wasn't here either. Let me see if that's, yes, that just got somehow typed in, and or I mistyped it. Why should I say typed in? And then we have to do this. Okay, good. So we got these guys here. Okay, and then so this becomes, or this quantity becomes negative the antiderivative of e to the u du, which is quite straightforward to obtain. Du, that is simply e to the u, so this is negative e to the u, or in other words, it is simply negative e to the 1 over x. Okay, I should have, I don't know why I'm becoming so lazy, don't even have to write much anymore. Okay, so here we got e to the 1 over x here. Okay, so if I look at this quantity, then what that will be, limit as x goes to infinity, right? Okay, of negative 1 over x. And then for the lower limit, we will have minus sign, and then let me just put that inside instead of just verbally describing it. Okay, and then we have this, and x will be substituted as what? 200 over here. So there we get 1 over x, as x goes to infinity, goes to 0. So e to the 0 is 1. So that limit is going to be negative 1. And then what we get? E to the 1 over 200. Okay, so what we got is that the size of the error, or an estimate of the error, is how much? We can just compute this. That's about 0.005001 if we round it here. Okay, so that means we are talking about that being approximately that. Okay, all right. So this is an estimate of this remainder here, okay? That, or this difference here, all right? Okay,